So example 6, we're going to find the area of a region. Find the area of the region bounded by the graph of f of x equals 3x minus x squared, the x-axis, and now the lines of x equals 1 and x equals 2. So we're looking at the lines x equals 1 and x equals 2, and we're looking for the area here. So it's going to be very similar to the last problem. So we know that our first value, x equals 1, is our a value, and this is our b value. So what we want to do is let's find our width first. So the width, if you use that formula, remember the width is b minus a over n. So it's going to be 2 minus 1 over n, or 1 over n. Then the height, remember that formula, is f of a plus b minus a times I over n. And so this is going to be a, which is f of 1, plus, it's really whatever that is, 1 over n times I. Then, what do we do with this value? We're going to plug it in here to find what that y value is. So this is going to be 3 times 1 plus 1 over n times I, and then minus that x squared. So 1 plus 1 over n times I, and now that is squared. So let's continue to simplify. We'll simplify this side. We're going to square that first. So this is going to be 3 times 1 plus 1 over ni minus 1 plus 2I over n plus I squared over n squared. And then now if I distribute this negative and then just combine like terms where I can, this is going to be 3. I'm going to distribute 3 plus 3 over n times I minus 1 minus 2I over n minus I squared over n squared. And then combining like terms here, this is going to be 2 and then plus I over n minus I squared over n squared. So this here is our height. So the area of the region is going to be the sum from 1 to n of 2 plus I over n minus I squared over n squared times the width of 1 over n. So don't forget, this is the height, and then over here, this is the width. So one way to do this is that we can either pull this to the front and then multiply it at the end, or another way to do it is to multiply it, distribute it right now. I find that distributing it right now is really nice because I personally sometimes make the mistake of forgetting it to distribute it all the way through. So that's what I'm going to do in this example here. I'm going to go ahead and distribute that 1 over n. This is going to be 2 over n plus I over n squared plus I squared over, not plus, sorry, that is minus I squared over n cubed. Careful of the signs. So now let's break this apart. So this is going to be 1 of n, and actually we can factor this 2n all the way to the front, right? Because that's all constant. So 2n, and then it's just multiplied to 1. And then plus, we'll pull out the 1 over n squared to the front, and then multiply that to the sum of 1 to n of I. And then let's factor out the 1 over n cubed, the sum of I equals 1 to n of I squared. Now we're going to go ahead and substitute. So this becomes 2 over n, and then, so this is a constant, so 1 times n is just n, plus 1 over n squared, and this is the sum of I to n, which is n times n plus 1 all over 2. Then minus 1 over n cubed, and the sum of I squared is going to be n times n plus 1 times 2n plus 1 all over 6. So now this is just all algebra. We need to get a common denominator and then evaluate. So 2 over n, 2 times n over n plus, this is going to be n squared plus n over 2n squared minus, we're going to multiply all of this through, so this numerator will become, so n squared plus n, multiplying it together. This will be 2n cubed plus 3n squared plus n. So that's what that changes to. So minus 2n cubed plus 3n squared plus n all over 6n cubed. So we need a common denominator. So 6n cubed, I need to multiply 6n squared to the first term. And then to the second term, I'm going to multiply 3n. And the last one stays the same. So now this is 12n cubed plus 3n cubed plus 3n squared. And then minus, I'm going to distribute this negative. Ooh, be careful. Minus 2n cubed minus 3n squared minus n all over 6n cubed. So let's combine like terms. We have some cubes here. So cubed, 1, 2, 3. So let's do that. 12 plus 3 is 15 minus 2. That becomes 13n cubed. And then let's do n squared. So 3n squared minus 3n squared, that is 0. And now we're left with a minus n all over 6n cubed. So now we can find the limit of 13n cubed minus n all over 6n cubed as n approaches infinity. That is going to be 13 over 6 square units. So yes, there are a lot of steps involved in doing this, and so you'll get lots of practice in the homework. And you'll get a practice problem to the right. So I want you to go ahead and try number 6. Find the area of the region bounded by the graph of x squared plus 2. We're using the x-axis and the lines x equals 1 and x equals 3. So try this out as practice. All right, so here's my work. Yes, lots of work. So the width you should have found as 2 over n, and then the width would be 3 plus 4 over ni plus 4i squared over n squared. And then you can see my work here on the right. So in this case, I did pull the 2n to the front and then distribute it all the way through. So again, you just have to be really, really careful with that. I do like the example, or what I did in the last problem where I distributed it right away, just because I find it, so I don't miss it. So you should have found the final answer to be 38 over 3 square units.